Hello, everyone. Welcome, welcome, welcome. Thank you so much for joining us this afternoon. I'm Lauren Turner, and I'm the Associate Curator for Contemporary Art and Special Projects here at the Acklen. And it is my distinct privilege to be able to introduce to you our two speakers joining us today. We are being joined by an artist and a composer, and they will be talking about all manners of intersection of art, science, music, and math. So from afar, we have joining us Kelsey Brooks. Kelsey Brooks is a former scientist who uses his background in biological and empirical methodology to adopt ideas found in logic and natural systems to build his artistic compositions that blur boundaries between the analytic and the creative. He's had solo exhibitions in Los Angeles, New York, Detroit, London, and Berlin. His work was featured as the cover art for the Red Hot Chili Peppers 2012 I'm With You record and the Flaming Lips 2013 Stone Roses LP. His work may be found in the public permanent collections of the Museum of Contemporary Art San Diego, the Crystal Bridges Museum of American Art, and the Frederick R. Wiseman Foundation. His painting, which you can also see reproduced here, One Pointed Attention To, is currently on view in Gallery 12 here at the Acklen. Our composer, Alan Anderson, has composed works for the Empyrean Ensemble, the Raleigh Chamber Music Guild, Speculum Musicae, Ensemble Ascolta, the University of North Carolina Symphony Orchestra, the UNC Chamber Singers, and many, many others who unfortunately I cut for brevity. His work has been acknowledged with awards or commissions from the Guggenheim, Fromm and Kusadevsky Foundations, Chamber Music America, BMI, the League of Composers / ISCM, both the national and Boston chapters, the Institute of Arts and Humanities here at UNC, and the Raleigh Chamber Music Guild. He's the recipient of the Goddard Lieberson Award from the American Academy of Arts and Letters. And after teaching music composition and theory here at UNC Chapel Hill since 1996, he retired at the end of last year, giving him more time to write, play the electric guitar, and improvise electronic music. Kelsey and Alan are here to lead us over about the next hour in a discussion of the intersections of art, science, music, and math, but I should mention that their conversation is a program that's being presented in connection with the Art Bridges Collection Loan Partnership and also the North Carolina Science Festival. We thank everyone for their support, and I encourage you to find out more about the Science Festival's offerings over the coming month at ncsciencefestival.org. And as a moment quickly of housekeeping, we will be taking questions and answers at the end, but I have been informed that we must clear out of this room at 4:30 for a room flip. So we will be taking a wonderful, fantastic field trip to actually see Kelsey's work in question in Gallery 12. So if you see me hustling you along, we're not trying to end the conversation, just move the location. So without further ado, I am turning it over to Alan and Kelsey.
Thank you, Lauren. So it's my pleasure to be here. Welcome to everybody for coming out this afternoon. As the introduction said, I am a composer. I have never thought of myself as a scientist, nor really as a mathematician. I was fairly good at math in high school, and I bemoan in the present, and for various reasons, and the sort of how that knowledge has sort of disappeared. Nevertheless, as a composer and as a musician, I'm involved in math all the time. In some cases, with conscious attention to it, but other times it's simply a matter of what we as musicians do. We're always finding ways to tune our instruments, a mathematical property, a mathematical computation that we make rather quickly. We're also finding ways of grouping measures of notes together, basic mathematical property that we're always involved in. But that said, I really make no claims about being trained in either of those areas. But in the course of our talk today, I'm going to show some ways in which math, and in particular one particular math series that is very dear to Kelsey and his work, how it can make its way into music as well. And basic understanding of looking at ways in which proportionalities or number sequences can make their way into music. And I hope this is the case that nothing that I play makes you think you've just demonstrated a math equation, or you've just demonstrated something that's mathematical. I hope it always remains musical. That's going to be my introduction, and I'm going to have Kelsey as our guest coming to us for today from San Diego. And really the reason this is all happening because of this work, give his own brief introduction to himself, and then we'll start getting into some slides and videos and music demonstrations.
Great. Thank you, Lauren, for that nice introduction. Alan, excited for this. So I'm a painter. I started out my life as a scientist. I studied microbiology in school, and then I worked for the Centers for Disease Control for a few years, and then I moved to San Diego to work at in the research department at a biotech company. I was working with viruses. So it's made the last 2 years pretty exciting for me. But actually, right before the pandemic happened, I did an entire show based on virus capsids, the shape of viruses. And so it was either the worst or the best timing ever, depending on how you look at it. Because I started out life as a scientist, I continue to think about the world as a scientist. So anything that has evidence to support it is something that I'm interested in. That's empirical methodology. And so I have made it a point to make art using empirical methods. In this case, that we'll be talking about mathematics, Fibonacci sequences, and prime numbers are an example of that. I also do art based on molecules, some of the molecules that I was interested in working with, and some of the analogs to the molecules that I was working with. So yeah, I'm excited for this.
Well, we have queued up here on the slides a short video that Kelsey prepared to give you really a sort of synopsis of how his work as a chemist, or work with chemistry, has transposed itself into his work as a painter. I think, if you think that's okay, we'll just play that video.
Yeah, I think that's good. This is a good time.
If chemistry has been neglected by visual artists, it might be explained by the simple fact that molecules are invisible.
Okay, so this is a molecular line diagram of serotonin. Molecular line diagrams are visual shorthands, or like maps that chemists like to use to show where each little tiny atom is located within the larger molecule. And interestingly, here we see that LSD, psilocybin, and mescaline all have similar molecular structures to serotonin. Acting at similar sites within the human brain, each is part of a class called neurotransmitters, which work by propagating signals from one neuron all the way to another within a given brain region. And these molecules are grouped together also as serotonergic agents and regulate a myriad of psychological states, including happiness, well-being, and spiritual states. Okay, so how do I make these paintings? Each one of these paintings begins by transferring the molecular line diagram onto the canvas. Then, at the precise location of each one of these little atoms, I place a dot. Then, I outline that dot again, and again, and again, and again, and again, until the painting surface is totally full, creating at the end an aesthetic view of this empirically derived scientific line diagram. I like to think of it as a colorful and kinetic representation of the tiniest pieces of our universe and of ourselves.
If someone could allow the non-chemist to see, in however abstract a form, what the chemist sees for only a moment, to understand that these black and white drawings of hexagons and zigzags are designed to represent something as rich and unknowable as the sum total of everything that ever was and will be, then the word chemical would never be used dismissively again. I think Kelsey Brooks' art does this.
When I was first approached by the Ackland to participate in this talk today, I asked, just only partly in jest, whether any hallucinogenics would be passed out at the reception afterwards. going to give the mic back to Kelsey and have him talk about several slides here in a row, which, well, you tell us what they are.
Sounds good. I didn't bring any psychedelics here, so so this is a molecule. So some of what you saw were neurotransmitter work in that video, and some of the analogs, the psychedelic analogs to those neurotransmitters. And then I did a show after that that was called Better Living Through Chemistry, and it was about the molecules that we use to feel good. And so this is a Xanax molecule, and this is the painting that I made of it. But you can see the molecular line diagram, and if you imagine picking that thing up and putting it on top of it, you would see that the location of the atoms is here. So yeah, it kind of makes a fun map. You can go to the next slide. So this is Zoloft.
Kelsey, how large are these?
So these paintings, I believe these are 60 by 84 inches. I think all these in the series, they're 60 by 84. So this is lithium carbonate. So this is the only psychoactive molecule that is itself an individual atom. And so it's stabilized using the carbonate, but lithium itself is made in the explosion of stars, and it just so happens to be very useful for stabilizing people's moods. So I thought it was an important painting to make. And so this is more, so I did a show after that was all about party drugs. So these are drugs that people take to have fun. MDMA, also known as ecstasy, was one of those. And you can see it's structurally very similar to serotonin, which is, I guess one of the reasons it works so well. Yeah, maybe the next slide. And this is mescaline. So this molecule is typically inside of a cactus. That's usually where people are. That's a natural source for these. You can isolate them and utilize them for these visionary purposes. And so I thought that was fun. This is one of the paintings that's in the collection of the Museum of Contemporary Art, San Diego. And strangely enough, don't tell the Museum of Contemporary Art this, but my dog vomited on the lower right-hand corner of the painting right before the museum came to pick it up. And so I cleaned it off and did the best I could. But these are the things that happen in life, and you can't make it up. But that's what happened to that painting. Don't tell anybody. And then this is the serotonin molecule. So this is the one that kind of started it all off. There is a story about why I started to make these molecules, but this is the first one. And it was after making this molecule that I was like, okay, this is something interesting. There's more green pastures to run around in here. Let's pursue this. And so I started these in 2012, and I continue them now. Not exclusively. I've gotten excited about other things, but I still paint molecules every once in a while.
I'm going to jump into the question that may be on some people's minds here. Actually, there are two. The second one I'm going to hold off on for a moment. What determines your color choices, say, in the serotonin painting?
So that's a good question. So the color choices are usually just a feeling. So in the case of the serotonin, they all started, the centers correspond to the different types of atoms. So all the hydrogen atoms are starting as yellow, all the nitrogen atoms started out as blue, and then they grow to connect from there. But each one is influenced or informed by my experiences with the molecules themselves. So I haven't taken every single one of these, especially the mood stabilizers and a lot of the party drugs I have not taken. Some of them I have. I'll leave it to you to figure out which ones. But yeah, I have, like with the LSD molecule, it's, for me, the experience of LSD was very colorful. And so I thought I needed to have every single color that I can make in that painting. And so that was how that one came about. The psilocybin one was all black. And that experience for me, the experience that I've had with psilocybin is very simple in comparison to LSD, and so I just wanted to show that. But yeah, it's more of a personal connection. Mm-hmm. Oh, there we go. That's LSD, yeah.
take the mic back for a second. So my second question, actually maybe I should go back, see if I can go back. Maybe I can't go back. It's okay. My second question was, you've plotted the map, you've mapped the compound on your canvas. They are canvases, yes?
Yeah.
Yep. And you've selected the colors, and then there's this vibration that happens in all your paintings. This blank slide right now is going to create a video in a moment, but I'm just going to ask Kelsey to introduce this video and the whole idea of the expanding vibrations and filling out the canvas.
Yeah, so the way the paintings happen is the beginning is just a dot, and then I outline that dot again, and as you outline that dot, there's imperfections that happen. You know, maybe like I kind of like to think of it as a record that is playing around, and the vibrations within the needle cause the record to hold the sound. I kind of have that same feeling with the painting that I'm doing. So as I go around, you know, they're just concentric circles. Every once in a while something happens, and then something that's out of my control. But once that thing happens, then I react to it again, and then again, and again, and eventually they all fill up. So when I get ready, the molecules are really exciting to paint because I don't know what it's going to look like. Oftentimes, with other series of paintings, I know what the goal is, and so I'm trying to achieve something. With the molecules, I just begin somewhere, and I lay out a series of steps, and the paintings, in a way, make themselves. I'm just there to facilitate that creation process. But that's a really exciting thing. And sometimes the results are great, and sometimes they're not. And so you never know what you're going to get.
So this is actually an important point and an intersection between both of our experiences. I hadn't heard Kelsey talk about this last bit, about essentially realizing the painting, you know, adding the ripples out and what might happen, the accidents that may take place or the collisions that may take place. And I would just pre-assert this before I play any musical examples, and that is that in my own experience in creating pieces of music in which some kind of number or some kind of pattern, some kind of organizational network is put in place, there's always going to be room for flutter or for some kind of disturbance or some kind of moment where you say, I'm going to, mathematician couldn't do this, but I'm going to fudge this a bit, or I'm going to move this over slightly, or something that happens knocks over the next event in some way. And I just grabbed this from what Kelsey just said, and that you have to remember that he had to create these in a studio. That was an action that was taking place. He was creating them. And the same thing with composing. I'm adding the things one bit at a time, having certain goals in mind, and I'm talking about goals like there's some number event some event that is supposed to be marked by because of the number pattern. Well, can I get there? Can I make it happen? Well, and there's an element in the studio, I'm going to say the composition studio and the painting studio, when you're executing, you're creating the art, a moment of surprise and fascination and anxiety and exhilaration as you're approaching these boundaries, or as the ripples head out one to another. Now we have, for the purposes of this talk today, sort of decided, it was easy to decide, it wasn't much debate back and forth, but that we would talk about a particular number series and how it relates to our work, or how it could relate to our work. And the next video is going to talk about this. This is the Fibonacci number series. Many of you may have heard of this before, but it kicks around, and it's a fascination to artists of various kinds. So we have a little video. Again, Kelsey has produced this just to describe this succinctly.
The mathematics underlying art. The revelation that simple mathematics can encode spectacular intricate structure adds to its beauty. It still looks the same as an image, but now you can, with your mind's eye, see it from another perspective. As an embodiment of concepts, it is both real and ideal. Conversely, the equity of the image enhances the mathematics. Frank Wilczek. So technically defined, Fibonacci numbers are a series of numbers in which each number is the sum of the two preceding it. but more broadly speaking, Fibonacci numbers can be understood as a set of relative relationships based on location and size. These relationships are found everywhere in nature and life. They're useful at modeling many natural phenomena, such as the growth of animal populations, like rabbits breeding under ideal circumstances, plant structures such as an arrangement of leaves around a stem, also known as phyllotaxis. Some pine cones and fir cones also show these numbers, as do daisies and sunflowers. The simplicity and beauty of Fibonacci numbers have motivated the development of matrix cryptosystems, which are useful in digital communications like digital television and digital telephones. They also exist within computer science to help create efficient data structures and algorithms used to make computation and search faster. Okay, so now I would like to describe how I turn this series of numbers into a painting. The first step is to multiply each Fibonacci number by a linear measurement. In this case, we multiply each number by 1 inch, turning a series of numbers into a series of measurements. Next, we take each of those linear measurements and draw a circle around it. I make a line around the circumference of the circle and then fill it up with other lines of varying color. Then that series of colorful circles gets placed inside of a larger circle. Other series of circles are added until that large circle is filled up. The edge of this large circle represents the completion of the sequence. Now that we have a completed circle whose diameter is itself created by the Fibonacci numbers, next I take this diameter as a starting point to begin creating yet another series of paintings that grow in the same manner, both externally and internally, using the same mathematics to underlie each step. The process that dictates the external dimensions of the circle is the same process that created the internal pattern on the surface of the individual paintings, creating a closed, recursive loop. This recursive loop can be played forward, creating an infinite, complex, and emergent system from very simple starting points.
All right, Kelsey, maybe you can talk us through the next few slides.
Sure. So I hope that video helps you kind of understand how I take Fibonacci numbers and turn them into visual art. And what you can see here is one of the paintings that I made using those numbers. It's a series of 5 paintings that all fit together, and you could imagine if I took a group of them and made a circle out of them, then that could become the beginning of another painting. And that process is called recursion. And it's definitely involved in music, the creation of music. It's involved in computer science, and it's involved in the natural world. And so it just, to me, these things, these number sequences, these structures are apparent in the natural world. In a way, Mother Nature created the universe using them. And so my feeling was, well, maybe they can also make a picture really nicely. And so that was kind of my experiment with these Fibonacci numbers, is how can I make paintings with them? And so this one you can see, this is just an individual painting with all of the pieces that we were looking at before inside of one painting. And this one isn't quite this large. It's maybe about half the size of that. But this was just another variation. You know, within the structure of Fibonacci, there's a lot of variations. And Fibonacci is also an interesting thing that it kind of devours your entire life once you start paying attention to it. And you start, I thought, well, maybe I need to start organizing my books using Fibonacci. Maybe I need to start laying out my bathroom using Fibonacci. And you'd get to some feng shui sort of harmonics that way. I don't know, but it did eat my world for a good 3 or 4 years.
It's a sort of transition between the visual images and some musical presentations. Actually, is this slide animated? I can't remember if this one is or not.
It should be.
Let's see if this one plays. Yeah. And a second one. who created the music for these?
So I was just gonna say I'm embarrassed because you're a real composer, but I made that just out of these weird sounds that I had in the studio, and I was like, oh geez, he's gonna be judging me for sure. So yes, I am new to this, so give me a little bit of time. The previous one was more focused on Fibonacci. This happens to be a psilocybin molecule, but it was just fun for me to try and create these things.
Oh, I think you did great. I actually like watching those, and the experience of the music and the visual the transformations visually are quite appealing. You could expand them. We could go 10 minutes on these, not longer. So we're at a place where I'm going to step over and start talking about the applications in music. I will first say that while I have used mathematical proportions in constructing music, it's not something I do consciously anyway, in every single piece I write. It's something that has happened. I've done it deliberately. I have never, until a few weeks ago, written a piece that was founded on the Fibonacci series. Because we were doing this talk, I thought it would be appropriate to give it a try. I taught music theory here at UNC for many years, and also taught music theory years before that, so I was sort of in the habit of creating demonstrations of things. So I composed a piece in which I applied the Fibonacci numbers in one to order some things that happen in the music. Now you'll notice that earlier in that video, Kelsey said he took the numbers and he multiplied them by a distance. I think you said inches?
Yeah.
Yeah, inches. And then he turned the result into the diameter of circles. So in my case, at least in this first example that I'm going to play, I took the Fibonacci numbers as being time distances, or as musicians would say, beats, some amount of time. So there are things that happen according to those number patterns. Something happens for 3 beats, something happens for 5. Something happens for 8, something happens for 13, for 21, for example. It's not necessarily in every case, but because I wrote a piece as a demonstration, an etude for myself to do this, I wrote a piece for piano. So a lot of things are, of course, as soon as the sound is struck, it decays. But when the next thing happens in a part, it's following along the Fibonacci series in one way or another. In trying to develop this, I started, actually I've got a slide here, I think, that starts flagging these things. I created a scaffolding. And outside, in music often, the thing that is playing the highest sound, the highest pitch, and the lowest pitch, our ears tend to be able to hear those the best. Outside parts, particularly when the music is rather dense. This music starts fairly transparent, but it becomes denser as it goes along. But I had one of those lines, the top one, in fact, starting and playing 8 beats before it moved on to its next thing. That's what those numbers are showing there. Simultaneously, starting exact same time, in the lowest register, there's a part that is doing something for 5 beats before it does its next thing, and does that for 3. So you'll notice that as these strands are continuing along, they're following the Fibonacci series, 8, 5, add those together, you get 13, add 13 and 8, you get 21. It keeps ... It goes on for a minute and a half or something like that. But you'll notice that these 2 strands aren't moving at the same rate. They're starting at different places in the Fibonacci series. So sometimes they coordinate and sometimes they don't. Sometimes they land together and sometimes they're moving separately. I thought of this as the scaffolding for this piece of music. I then, after I had this all in place, I went and added a filler. In musical terms, we would often describe this as being the music's surface. It's the part that's moving the fastest. It's the part we will tend to register as creating a forward motion in the music. It turned out that by the way I figured the number series, that surface part ended up sounding like the metrical poetic foot called the trochee. I just heard it kept happening in the music, and that's why I came up with this title for the composition. For those musical enthusiasts in the room, I would just tell you that the 2 outside voices, the one in the treble and the one in the bass, are moving in what's called a mirror canon with one another, just to impress you. Yeah. That is, when the top voice goes dum, dum, goes down like that, the other voice, dum, bum, will go the opposite direction. But of course, they're moving at different speeds, so they get out of sync with one another. You're not going to necessarily be conscious of this. I'll just tell you it's in the background, which raises an important issue. Do we hear the Fibonacci number series going on? I doubt it. But it remained, nor would I say I necessarily thought when I saw Kelsey's painting that that's what was going on. It's interesting now that I know it from him, to be able to understand things in a certain way. But this is what I'm about to say, what I've been saying, I should really, that's the terms I should use, is true about lots of things in the way that music is constructed. We don't necessarily pick up the devices that the composer used. It's instructive when we learn about them, but it's not necessarily what we will always be perceiving. I say I've added a third voice and eventually a fourth voice. I have an example here that will be the computer attempting to play this. So you'll notice, unusually for a piece of music, you can't see all the lines. I'm sorry about that. But you also can see that I've done some annotation in here. That's to prove to you that they're all Fibonacci numbers, one way or another, my effort to do that. Important also, among the things that we've been saying is nothing that we have done is inevitable. Somebody else taking the Fibonacci numbers and applying them to art would come up with something completely different. Likewise in music. This is just what I came up with, all kinds of ways that this might be realized. There is or has been, I'm not sure it's happening so much anymore, but there used to be a little cottage industry in music theory of going in and finding Fibonacci relationships in pieces of music. Sometimes it was probably true. In other cases, it may have been, if you look for it, you can find it. There certainly are people that have done it deliberately, such as this, but others as well. There's a very famous piece by the German composer Karl-Heinz Stockhausen, in which, if you look at the score, you'll see that the measures are all Fibonacci numbers, almost entirely Fibonacci numbers, I should say. Or the most famous one, sort of started the cult of Fibonacci, would be the people who have analyzed Bartók's music. In some cases, I'm sure it's there. Other cases, it may be, okay, you found what you looked for. And even in earlier music, some of the concepts of growing proportional relationships certainly do play out in music. There's an example that to me seems convincing, although I'm not sure that Beethoven really was applying anything in relationship to Fibonacci numbers or its close companion, the golden section, those relationships. But with just having put those words in your head about growing dimensions, if you go back and listen to the first movement of the Moonlight Sonata, you might say, oh yeah, there are landmarks that are growing in proportion as this first movement is progressing. you want to say anything?
You're doing great.
Okay. Like I said, I wrote that little piano etude in the last few weeks. But before, I had an interest in an inspiration taken from architecture, sort of more than science and per se. And I've just thrown some examples together here of, I guess this didn't all show up in the screen, but some examples of architecture in various ways. And what's interesting, in fact, about these first three examples, the Palladio, and then that ideal city painting, and then this Frank Lloyd Wright house, is that circles are all involved. And I picked them particularly because of Kelsey's paintings with the importance of circularity, circles in them. But also this kind of conception by the architect Peter Eisenman of taking cubic space, the shape, the form of potentially a living dwelling, and chopping it up in various ways. Those things are very musically stimulating to me. But in fact, one prosaic example that actually influenced me is that chapel. There are thousands of those in Italy, but my wife's son and I lived in this town, the undistinguished town in Tuscany for a number of months many years ago, and I could see that chapel from my window. And despite all the beautiful Renaissance architecture that was around, it was that made me think, I want to try to write a piece of music that had that kind of simple simplicity to it. What I found is that the simple simplicity can become complicated very quickly, again, which is something that Kelsey emphasized in the way that he was painting, how complexity just grows once you start the process. There's just a sidelight about your painting that's here, the one that's showing. It seems to me that it shoots out of the frame. It doesn't stop I got to stop. The painting's only this can be this big. It's got to fit through the doors of the Ackland somehow, you know. So here, follow along. I'm going to create a piece of music. I'm going to have it be 24 units long. That's the whole thing. Those 24s will, in fact, turn out to be measures. So it's not very long. I'm going to take those and divide them in half. Oh, because that little chapel was symmetrically arranged. It seemed to be in half. Somebody in here needs to be thinking, okay, that's fine. I can see the entire chapel. I can't hear the entire piece. I don't know where the middle is. I don't know when I'm there, and I maybe not know until sometime afterwards that there even was a middle. But I'm starting this way anyway. I'm laying out this foundation. I'm going to take that full distance and divide it into 3 parts. I'm going to take it and divide it into 4 parts. And in doing so, along that the thick line that I started with, you can see these hatches. That's where these cycles will intersect in relationship to one another. Well, those cycles, if I divided that 24, sort of counted it up, those nodes are groups of 6, 2, 4, 4, 2, and 6. Just those lengths in relationship to the whole. Well, I took those and put them down to simpler numbers, divided by 2, and decided, compositional choice, prerogative of the artistic choice, of not to emphasize the middle, to take the 2 4s and not group them as 2 plus 2, but subsume them as a single 4 unit. So that became a basic proportional scheme for me. Subsequently, Portmac, I should interject here, that when I'm thinking of the whole, however long it may last, and it's only, I tell you, the piece that I'm going to play this piece in a minute, it's 1 minute and 44 seconds long, but when I divide it into those chunks, those are still rather long. They're rather slow in terms of when they occur, spaced out. I need something faster, and this is, again, where both of us are trying in the process to find a route from the background to the surface. What's the thing that's going to occupy the finest grain of detail? And so I'm trying to move towards that. So I subsequently divided those cycles into other parts, groups of 3, groups of 4, and groups of 5, and came up with a I've got to find a way to rhythmicize this. I've got to notate this. It turns out I had to use the lowest common multiple, 720 of those. And then I had to figure out how to notate that. 24 measures, 5 beats each, each beat divided into sextuplets. Are you with me? Yeah. Anyway, I had to find out where these events happen in the total span. There was actually two more steps. I had to take those first 45 septuplets, that's from first downbeat to the first place where one of those nodes struck. I'm going to take that and subdivide it into that basic proportional scheme. What was it? 3 to 1 to 4 to 1 to 3. I'm going to find that rhythm. What makes that? Then I'm going to subdivide that. I'm going to put underneath that a basic pulse that divides it equally. This is where the sound gets very complex. This piece is very different from the previous one. It's also for piano. It's extremely complicated to say in its sound, but it's something that I love. I actually think this is one of my pieces I'm proudest of. I've called it rolling stock because the sound of this thing being played on the piano sounded to me like a freight train rolling by. The title has nothing to do with Italian architecture at all. This is the way it sounded. And this is a performance by Alec Harris, who, by the way, lives in San Diego. Let's see if this plays. As it say, it's 1 minute and 44 seconds. It gives you some idea. It is clangorous. Like I said, it's noisy. Yep. So that gives you an example of one way that I've used numbers. Finally, one of the things we set up for this Ackland exhibit of Kelsey's painting, there's a sound file that is attached to it. Inspired by his video of working with Fibonacci numbers, this is the first page of, only 2 pages, of my sketches for coming up with a piece to accompany his painting. And you'll see the expanding circles as in his description. And you can also see the expanding units built on increasingly large Fibonacci numbers, and some of those numerals you can probably read. The expanding circles are realized in just the number of parts that are playing. So when it reaches the measure 40 there, I guess there are 13 parts that are placed in the track. This is all electronic score. Everything is made with electronic sounds. And there are 21 over here that are sounding. It becomes rather dense. It starts simple, but becomes denser as it goes along. One last thing I should say about this is that the circularity of Kelsey's painting intrigues me. What's the musical analog for that? Would be something, potentially, it could be something playing on a loop, but this is not being looped. When it reaches the, I can't remember the number, I guess the 21, when the 21 cycle, 21 is the next number in the sequence, when it reaches its end, the music jumps back to the very beginning. And my effort to suggest that this is circular and potentially could go on forever. And the way I was fascinated by his paintings, the fountains of Fibonacci shapes exceeding out past the end of the canvas. I'm not going to play this. I have a sound file there. I hope that people going through the gallery, going to the painting, can access the file, which I understand the museum has been able to access on your phone. That's the end of what I have to say. I'm going to get back to Kelsey and see what happens.
There's a lot to respond to there. I really liked, one of the things that I was saying before is the number sequence, the Fibonacci numbers, kind of ate my world in the sense that I was spending all day structuring pictures using them, and then I couldn't stop there. I was organizing my house and spatial layouts for sculptures, and it looked like Alan was enjoying some of that eating of his world. He was like, well, let's just keep going, because you really can, and there does seem to be something that is like you're like an archaeologist uncovering some hidden information inside of it. And I like how you're mining it and organizing it into music, and I'm mining those same ideas and organizing them into visual art. And I just think it speaks a lot to, what am I trying to say? So life uses structures over and over again to produce various means. So if you have a centipede, it basically copies and pastes little body segments over and over again until it fits a perfect evolutionary path for that centipede. And in a way, it seems like we're taking these structures that happen to be in nature and we're copying and pasting it into, for me, visual art to see, like, is that going to be a good evolutionary fit? And the way I judge fitness is, does the painting sell, right? It's really simple when you're in a commercial business. For Alan, maybe it's a little bit more complicated, but yeah, those were the things that I was thinking.
I want to return to a question or point that I made earlier, and just to ask Kelsey directly. When you are setting up paintings that do emanate from points, can you give any examples of places where you have, or have you, fudged the numbers?
I don't know how to respond to that. Every one of the paintings is, at the end of the day, a painting. It's not a perfect mathematical sequence. At the end of the day, I'm an artist, and I'm trying to make good pictures. So yes, the numbers get fudged. I have an idea. I want to make something. But if I'm going down that road and it's not working, I'm happy to rewind and begin again and adjust as needed. So I think what I discovered about Fibonacci is it is a really fun way as an artist to organize things. It doesn't necessarily mean that it is more visually pleasing. So after 5 years of working with this number sequence, I don't know, and maybe, of course, maybe somebody, a better artist could figure it out, but I don't think there's anything there in the way that I had assumed or hoped that there was something there at the beginning. I don't think it produces more beautiful paintings than somebody who organizes them, who uses prime number sequences or any other number sequence or no number sequence. I don't think there's anything there, but like I said, it's so fun to use it.